Rhombi and squares. Alright, rhombi is just the plural form of what do we call just a singular rhombi? A rhombus. Yep, good. Rhombus. So rather than calling it rhombuses, we say rhombi. So that would sound weird to say rhombuses. Okay, so a rhombus is a type of parallelogram. Bring him, dear man. Okay, where all sides are congruent. Okay, if you need to write by that congruent, if in parentheses or next to it, if you need to write that word equal, to remind you that that's what that means. Congruent means equal. Alright, you're going to get a glue in. With this glue in, you're just gluing it either on the left or the right side. No cutting is necessary, so you should be able to fit it in if you just started on a new page with us today. Just gluing it in on the left or the right side. As you find your glue, if you want to find those colored pencils, we can do some marking up.
Is there an action on
Alright, so get that glued in, and then if you want to grab out some colored pencils, we're going to mark it up a little bit. Remember, if you're not using colored pencils, you still want to do these markings, like these congruent symbols. Okay, I'm noticing a couple people that don't want to use colored pencils, and that's okay, but then they're leaving things blank. Point of the colored pencils is to show matching parts, but it's also just to at least get those markings on there. Alright, as we work today, I'm actually going to use a variety of colored pencils, probably like 4 for this first one, and then we'll drop down to just a couple. Alright. So, in this one, again, we're just going to go through kind of the big ideas of a rhombus. So, we have the DKLM. When we name a polygon, we always name all the vertices, all the corners. We could go in any order, but we have to make sure we're going in a connected order. So, we couldn't do DLMK. That wouldn't go in a connection. So, you can start anywhere and just make sure that we're working our way around. On the first day I'm back, you're going to go to the bathroom right away? Bruh. Killing me. Alright, so DKLM is a rhombus. And that tells us a couple of things. Okay, first off, because it's a rhombus, we know that all the sides are congruent. So this is where I'm going to grab my first colored pencil. If you're not using colors, remember to still do these markings. So the first thing that we know is that all the sides are congruent. Because it's a parallelogram, we know opposite sides are congruent. So we've always known that with parallelograms. But because all sides are congruent, we can do this too. Abdirman, put away your phone. Okay. Something that's different about a rhombus. So everything about parallelogram applies to a rhombus as well. So opposite angles are congruent. So if you look at all of angle M, that'll be congruent to angle K. We know these two add up to 180. All of those good things. Diagonals bisect each other. Okay. So because of that, we do know that the diagonals are perpendicular. So when it's a rhombus, the diagonals are perpendicular. What does perpendicular mean again? They intersect at what degree? 90. Good. So that's 90 degrees. Okay, so as I look at my diagram here, my picture, which ones are the diagonals? What segments? Abdirman, you just fully put your notes away and then now we're just on your phone. You did the literal opposite of what I want. Okay, you're not on your phone, but take your notes out. What are you doing, bro? Come on, man. Alright, which ones are the diagonals? From where to where? So diagonal, remember, cuts through the shape. So what's cutting through the shape here?
MK.
Good. M to K is one diagonal. What's our other diagonal? D to L. Good. Or we could say LD. Okay, now these are perpendicular, which means that they cross at 90 degrees. So what symbol can I use to show that it's a 90-degree angle? What can I put on the drawing to show it's 90 degrees? Yeah, that little square, that little box. Okay. All right, last thing that we know that we're going to do, and then we have a couple examples here, is that we know that the diagonals bisect each angle. The diagonals bisect each angle. What does that word bisect mean again? Yeah, cuts it in the middle, or cuts into two equal parts. You need to write that down. It's your choice. If you feel like you know what bisect means, you got that. You don't have to. Alright, so as we take a look at this, what that means is as I look at angle K here, this diagonal MK is going to cut angle K into two equal parts. So this left side, or kind of this upper part, would be congruent to this bottom part. Okay, but then because it's a parallelogram, we also know opposite angles are congruent. So then down at M, we actually end up with the same amounts down here, M here. For these angles down at the bottom and at the top, remember we have to use 3 letters to describe those. You can't just say angle K when we're talking about the little angle there. We want K to be on the middle point, so it'd be DKA or DKM. Down here, M is the vertex, so we would want M to be the middle letter. Okay, and then the same thing happens in the other corners. So I would know that at D, but this is going to be a different angle, so I'm going to use 2 arcs. And 2 arcs. So it's different than M, but I do know across D is going to be the same as L. So all 4 of these angles are going to match. All right, so even if you're not using colored pencils, these markings are going to help you identify which parts are the matching parts. All right, if you want to draw a line across saying that that is kind of all the definition information that we're going to go through, and then we have a couple examples that we will jump into. All right, for this next one, we know ABCD is a rhombus. The problem is telling that to us. We're not identifying it as a rhombus, it says it is a rhombus, period. We're going to do 2 problems with this one really quick. The third problem, this one will be a little bit longer, and then we're just going to end on a definition for square. All right, so for number 1, we're going to say if AD is 7 centimeters. What is CD equal to? So first, take a moment to locate where those are on the diagram. Where is AD? Is it a side or a diagonal? What is it? Is A to D a side of the rhombus or the diagonal of the rhombus? It's a side, A to D, that's 7. And it's asking us to find the other side, CD, but it's not the opposite side, it's kind of the next to side, it's adjacent to it. So, but in a rhombus, what do we know about all the sides? They're all equal, so what is CD equal to? 7. Oh my gosh, so genius. Done. All right, number 2, we're going to use the same diagram here. This time we're going to say if BD equals 4 centimeters, PB is equal to how much? So this is actually this part. BD, is that a side or a diagonal? Good, it's a diagonal. We do know at angle P it's a 90-degree angle, but this actually goes back to when we did the parallelograms. So I'm going to just pop over this for a second. But the parallelograms, theorem 5, told us when I have a parallelogram that point in the middle where the diagonals cross is the midpoint. So we have matching parts here. Okay, in a rhombus, all 4 of those will all be the same. Okay, so the diagonals bisect each other, but they're also at 90 degrees. So if BD is 4 centimeters, that's the whole way across. How much is PB going to be? How'd you figure out 2? Good, cuts it in half. So you can say 4 divided by 2 is 2 if you need that written there for just your mind work, your thinking work. But then we know PB is 2. Some of you were able to do that probably without thinking 4 divided by 2. You were just like, oh, there's 4, so it's 2. Perfect. Great. All right. This problem here, this is number 3. Again, we know it's a rhombus. This one we're going to talk about angles, not sides. So we need to find the measure of the angles of 1, 2, 3, and 4. So we're going to find measure of angle 1, measure of angle 2, angle 3, and angle 4. So we are given an angle here. Which angle do we know the amount of already? Good, the 32 degrees. If we named that angle, how would I name that angle with the 32? EA, what did you say? BAC? Sorry, BAC. Good. BAC. We need A in that middle, and we need to cut across. Beautiful. Love that. All right, so which angles, now when we have numbered angle problems, I notice some students, they want to just start at 1 and work their way through 4. These numbers are just on this diagram. They're not telling you logically where to start. So we need to think through, where should we start? Which angle do we know without having to do a lot of work for? Look back at the diagram you marked up. Why? That's right. What's the same?
3.
Good. 3 and 4. I'm not 3 and 4, sorry. 3 and the 32 is the same. They're across from each other. Remember, these are all congruent. So this is the same as this, which is the same as this, which is the same as this. So all 4 of those match. So angle 3 is how much? 32 degrees. Nice. Does that mean angle 1 and angle 2 are also 32 degrees? No, not quite. Okay, remember it's the ones across from each other match. It's not necessarily the ones next to each other match. All right, but we also see that we have these diagonals, A to C and B to D. And when I see diagonals crossing in a rhombus, what did we say about the diagonals crossing in a rhombus? Say it a little louder. They're perpendicular, which means how many degrees? 90 degrees. So if you want to put that little box there, which means how much is angle 4? 90 degrees. All right, so our last ones are angle 1 and 2. But what do I know about angle 1 and angle 2? Yeah, they're going to match because they're together. So if I find angle 1, I know that's going to be the same as angle 2. These are going to match as each other. Or if I find angle 2, it'll be the same as angle 1. So what we're going to do is we're actually going to break this apart into that little triangle. See how there's a triangle there? So I'm going to redraw that triangle off to the side just for my thinking. Again, when you do your homework, you might not redraw it. You might be able to just see that visualization, that zoomed in version. We have A, B, and then it's coming down to E. And in this triangle, we know that angle A is 32 degrees. How much is angle E? 90 degrees. So you can put 90 there, or you can do a little square, either one. And we're trying to find angle B. And this is a problem we've been doing since last trimester. Subtract 90 and 32 from what? 180. Good. So, again, this one is the one that it's interesting. A lot of you guys do this different ways. You're just finding the missing angle. We know they all have to make 180. Some of you like to add these together, then subtract from 180. I like to just do it all at once. So I do 180 minus 32 minus 90. And we get 58. So that means angle 1 is 58 degrees, but angle 2 is sharing a corner with it, and remember it bisects it, which means that the two parts are equal or congruent. Good. So 58 and 58. So when we did this, did we go in order? 1, 2, 3, 4? No. So if you need to write like little numbers next to this, that this is like what we did first, second, and then we did third, and then fourth. If that helps you to write those and you're not going to get confused with the 1, 2, 3, 4, if you want to just like number the order we did it, that can be helpful. I did it really light so you can't really see it, sorry. It's been a while since I've been writing in a notebook in front of you guys. All right, last one. This one we're just going to talk a little bit about definition. This last one is something you guys are very familiar with. What kind of shape is this last shape? A square. So let's just talk about what a square is. Everything that we have talked about with parallelograms and rhombuses or rhombi applies to a square. So opposite angles are congruent, opposite sides are congruent. But in this square, we do know that all sides are congruent. So if you want to say all sides equal, or you can say congruent. But what else do we know about all the angles? Say it again. They're 90 degrees, so all the angles are also equal to 90 degrees. So all sides are congruent, and then we know all angles are 90 degrees, so they're also congruent. Going back to, way back to before break, what do we call a shape that is all sides are the same? Starts with an E. Equilateral. I know. I just wanted more people to say it. And then what do we call it when all angles are equal? Good. Equiangular. So together, when I have an equilateral and equiangular shape, there's a special name for those types of polygons when it was both. Does anyone remember what do we call it when it's both equilateral and equiangular? If you need to flip back, find that at chapter 6 introduction. We had equilateral, sides are congruent, equiangular, angles are congruent. If they're equilateral and equiangular, they are regular. So this is a regular quadrilateral is what we can call this. We're not going to do any examples with squares because squares is everything we've learned from parallelograms, rhombuses, and rectangles all apply to a square. So it's just we're combining literally every shape into like that more specific. This is the most specific quadrilateral we can get to.